start the class. So now we have to understand the relationship between software, hardware, and firmware. Umar, let me make a very simple diagram. For example, we have Photoshop, or I can say some kind of Illustrator software, right? And it's a application software, right?
Yeah.
So application software that is actually installed on the top layer, we have already discussed in this thing, Photoshop. Then Photoshop communicate with the operating system, whatever the operating system you have, right? Then operating system communicates with the hardware, right?
Yeah.
So what happens? Is it done? No. Then hardware definitely communicate it back to the operating system, and operating system reply it back to the Photoshop. And you can see the results on the screen or on the speaker and so on. So let me say, if I can draw a simple diagram. For example, we have this software, Photoshop, P as Photoshop. So Photoshop actually talks to the operating system, OS. Umar, clear?
Yes.
Which in turns talks with the hardware, and then hardware talks back to operating system, and then finally with the application software, which is your Photoshop. This is what happens. This is how the software interacts with the operating system, and operating system handles with the hardware, and it communicates back to the application software, whatever the application software we are using. Umar, clear?
Yes.
Okay. So we are good with the root uh, operating system. Then we have sorry, the hardware. Then we have operating system. Then we have application software, and so on. Right? Okay. The new thing that is coming up, that is your firmware. Have you ever heard about this thing? Firmware.
Yes.
Umar, what happens when you turn on your PC, then what happens next? Your system, your computer your PC looks for the ROM. And what exactly is in the ROM? ROM has a series of instructions. ROM has instructions stored by the manufacturer at the time of manufacturing. We know it, right?
Yeah.
And these programs are actually contained in the program. We call it bootloader. Bootloader, and sometimes people call it bootstrap loader. You can call it anything. Bootstrap loader, bootstrap, it's the same thing, right? Bootstrap loader. So then what happens when you turn on your PC? It looks for the ROM. ROM has actually the series of instructions which is stored by the manufacturing process by the manufacturers, and this is called bootloader. The instruction these are contained in the program, we called it bootstrap or bootstrap loader. Am I clear?
Yeah.
The initial process is handled by initial process is handled by BIOS. Have you heard about this BIOS? BIOS mean basic input output system. Well, sometimes we refer this as a firmware, right? We also refer this BIOS as a firmware. The firmware, if you can see this diagram, okay, let me make it again. So you have now application software on the top of it. You have application software, then you have operating system, then you have firmware. This sits between hardware and operating system. This is your firmware, or you can call it bootstrap loader, right? And eventually at the end, the hardware now it communicates it back to the firmware, and firmware communicates back to the OS, and OS respond accordingly to the application software. So remember one thing, this firmware, it provides a low level control for the devices, right? So firmware, now we know what is the relationship between the application software. Then we know what is how it interacts with the operating system, then hardware, then firmware. Is there any question about firmware?
No.
Are you sure? Clear?
Yeah.
Okay. By the way, Umar, did you get a chance to see the video that I uploaded? That
No,
was about
I didn't see the
fetch.
video yet.
No, I'm talking about the fetch, decode, execute cycle.
No.
Oh, man, you missed the video. Okay. Anyhow, you already attended that class. So now we are talking about what is an interrupt. The other day we discussed about interrupt, that was the function of the operating system. Now we are talking about the interrupt which happens during fetch, decode, execute cycle. What is an interrupt? So by the way, this is very interesting. It's not boring if you pay some attention, right? Okay, what is an interrupt? We know, Umar, we have this cycle fetch, then we have decode, then we have execute cycle. You know it, right?
Yes.
Okay. So we have software in our computers. We have software in our computers, right? No matter it's a utility software or application software, and we have hardware as well. For example, we have this keyboard A, S, D, F, etc., etc. This is your keyboard. This is your printer, and this is your scanner, etc., etc. Right? So these input devices, output devices, and the software, when they need and attention of the CPU when hardware devices, when hardware devices or software requires CPU attention, then it sends the signal. Then it sends the signal to CPU, right?
Yes.
Okay, Umar, during that process, fetching, decoding, executing, CPU also find it out, is there any interrupt? Every time during the fetch, decode, execute cycle, checking is there any new interrupt to be handled. For example, if I can change this diagram, for example, we have, let me extend this diagram, fetch, then we have again decode, then we have again execute. Now let me add another module that is called interrupt. Umar, clear?
Yes.
So what happens when there is an interrupt? The processor will need to stop executing the current program to run. What happens? Shall I write this one?
Yes, please.
Okay. When CPU receives an interrupt, processor will need processor will need to stop executing the current program to run. By the way, we can also call it by the, no, this would be informal, right? So that is called interrupt service routine. Interrupt service routine. More clear?
Yes.
Okay. So if I explain it more in details, interrupt service routine, that is simply a program with a set of instructions that need to be fetched, decoded, and executed to carry out the operation of the interrupt. ये लिख दूं? If you want me to write it, लिख दूं मैं इसे, उमर?
Y- Yeah. Yeah.
Okay. If the interrupt service routine, I am making it short, interrupt service routine is simply a program with a set of instructions that need to be fetched, that need to be fetched, decoded, and executed to carry out the operations of interrupt. Operations of interrupt.
Yes.
Okay. Now you need to recall the diagram. Let me make it again. That is fetch, decode, execute cycle. For example, we have program counter register. For example, we have this instructions stored in the program counter register, and we know it that their data is transmitted to the MAR memory address register through address bus, right? Umar, clear? Remember that?
Yeah. Yeah.
Okay, then memory address register, it's a RAM, main memory. It knows the address of the location. For example, we have this data on that location, whatever the location is, 1010011. This is the location, and that is the contents or data. So that data is transmitted to MDR. Umar, clear? A
Yes.
copy of this data that is transmitted through data bus to MDR. Later on, it will be sent to the CIR. And we know that fetch cycle is completed over here, right? Is that
Yeah.
clear? You recall all these things? Thank you. Umar,
Yeah.
okay, so what happens? What is the purpose of telling you this thing? What happens when interrupt is generated by any software or hardware to gain the attention of the CPU? CPU stop doing the current task. We call it suspending. Suspend कर देना उसको, right? It suspended the task and it look out for the interrupt. अब देखो, we have the data, we have the address in PC, we have the address in MAR, we have the data in MDR. So what happens with this data? So all this data that will be forwarded to the memory stack. For example, this is memory. So what happens? This data, PC means this PC, it has a address, for example, 1010011, and this is the MAR contents 00010. Then we have data MDR, then we have the data in CIR register. So all this data that is temporarily shifted or transmitted to the memory stack. Stack mean,
In
what is stack? Umar, do you know what is stack?
no.
For example, you have a library and you have this book, right? So you place another book over the this one. So you again put up another book. So this will create a stack, means this is the top book and the middle book and the lower that you place it on the very first time, right? सो ये एक दूसरे के ऊपर जो बुक ऊपर नीचे जो बुक्स रखते हैं, इट इज कॉल्ड स्टैक।
Yes.
उमर क्लियर?
Can yeah, but can you summarize this?
हाँ, श्योर। सो इन if I summarize this, if I make it more simple, okay, the interrupt is received by the CPU to gain attention by the hardware or the software, right? And
Yes.
the CPU is busy all the time in doing this thing. And what is this thing? Fetch, decode, execute. If the CPU gets the attention of the hardware or software, as I represented this in this diagram, and we call it interrupt, right? So CPU stop doing the thing, जो काम कर रहा होता है उसको वो सस्पेंड कर देता है, फॉर पास कर देता है फॉर सम टाइम, राइट?
Yes.
So what happens then with all these temporary values which are stored in the CPU registers? These values will be stored in the memory and we call it memory stack. These values are stored temporarily in the memory stack. Am I clear?
Yes.
Okay. So another interesting thing. Say for example, let me say it. Uh, let me say it I1, interrupt 1. Again, what happens? It continues the fetch, decode, execute cycle again. Again, the CPU receives an interrupt. Now the data in the PC, the address in the MAR, the contents in the memory, and the contents in the MDR, they will be definitely changed. So again, the new data of the registers MAR PC, for example, 00001, this is the new data address in the PC, and we have the address in the MAR, we have the address new data contents in the MDR, and so on. So this is on the top. This has higher priority interrupt. So what happens, उमर, जब भी कोई interrupt receive होती है, the contents in the temporary registers of the CPU जो हमारे हैं PC, MAR, MDR, these were placed in the memory stack. ये data structure भी हम कहते हैं by the way उसको. These value are pushed onto the stack जिसको मैं memory कह रहा हूं, right?
Yes.
उमर, confused?
Yes. No.
Okay. So what happens? They are pushed. So what happens? An interrupt has, for example, come along. The previous program, कौन सा program जो execute हो रहा था? The previous program has been suspending and the data has been stored in the stack frame, which is I did in the RAM. ठीक है? ये जो मैंने ये किया
Yes.
हुआ है. उमर क्लियर?
Yes.
Okay, what happens if the CPU again receives a high priority interrupt, then this will be pushed on the top of the previous data. ये जो डेटा है यहां पर इसके ऊपर स्टैक इसीलिए हम कहते हैं इसको. ये एक चीज है, इसके ऊपर दूसरी चीज रख दें. सो व्हेन यू पिक अप द थिंग, डेफिनेटली आप इसको सबसे पहले उठाओगे, इसको बाद में उठाओगे. दिस इज द लास्ट वन दैट यू आर गोइंग टू पिक इट अप, राइट?
Yes.
So that will be released, so that will be entertained. And what happens when the interrupt is entertained, then the same data, Umar, let me use this red ball pen. So this data PC, MAR, MDR, whatever the data is, that is stored again back to the relevant registers for execution. Again, let me summarize this in simple words. CPU receives the data from hardware and software. Not receives the data, in fact, a signal, we call it signal, to get the attention, right?
Yes.
Okay. So what happens? CPU that is already in the process of fetching, decoding, and executing cycle. When it takes the signals from the hardware or software, then it stops doing the current task, whatever it is doing, right?
Yeah.
Okay. Then what happens? The value stored in the CPU registers, which are program counter, MAR, MDR, CIR. So the data will be transferred from these registers to stack, memory stack, temporarily. Umar, clear? Why,
Yes.
why this data is transferred to memory stack? So that the interrupt, now the interrupt, because now the interrupt is generated, the address of interrupt in the program counter will be changed, MAR will be changed, MDR will be changed. So when the interrupt is done, this data, which is stored in program memory stack, this will be retrieved back to the corresponding registers. That's it. This is the total story.
Okay.
Umar, clear?
Yes.
Are you sure?
Yeah.
Or if you want me to repeat it, I can do that.
No, it's okay.
Okay, so Umar, we have to face these interrupts on a daily basis. For example, say for example, you are playing a game. You are playing a game, for example, Need for Speed, and that is loaded in your random access memory, right? It is taking your
Okay.
space 4 GB, and some other programs they are taking 1 GB. You have opened Google Chrome, etc., etc., and the system files, operating system files, right? So sometimes क्या होता है? Sometimes your system that goes into halt position. Halt mean it won't be responding to your request for whatever you do with your computer. You press control or delete. You press. This is very powerful interrupt. Control or delete. Alt F4, nothing is happening, right? So eventually you have to turn it off by plugging out the power cable, right? Or forcefully
Yes.
you have to press the button, right?
Yeah.
Okay, so there are some priorities. Let me tell you, there are some, by the way, there are very complex priorities, but if I see your syllabus, then you need to understand, beta, we have interrupt. So just a second, let me use this one. Let me say, this is interrupt, and फॉर एग्जांपल ये मैं एग्जांपल भी दे रहा हूँ आपको एग्जांपल्स इंटरप्ट हार्डवेयर इंटरप्ट्स व्हाट आर द हार्डवेयर इंटरप्ट्स नंबर वन पावर सप्लाई पावर सप्लाई दैट इज फेल्ड आपका डेस्कटॉप कंप्यूटर है उसका हीट सिंक खराब हो गया है योर पावर सप्लाई फेल्योर देयर विल बी अ पावर सप्लाई फेल्योर राइट or sometimes you reset the button or restart the button, right? Am I clear?
Yes.
Or sometimes your computer that goes in the hibernate state. That is called hardware interrupts. Umar, clear? Are you writing?
Yeah. Yes.
And then we have user interrupts. User interrupts. User interrupts mean, for example, whenever you move the mouse, or when you hover the mouse on any object, hover the mouse on any object, that is a user interrupt, right? And the second one, I should say, keyboard presses, whatever you press the button from the keyboard, that is a user interrupt, clicking, tapping, etc., etc. Umar, clear?
Yes.
So you need to know, okay, what are the hardware interrupts, what are the user interrupts, what are the software interrupts. Software interrupts, for example, mm, if there is a kind of overflow, yes, or if there is some abnormal results, let me say illegal instruction received by CPU, or let me say encountered, or what else? Software interrupt. Mhm. Okay, a new login. Okay, new login request. There may be some other as well. Okay, so software interrupt. Now we have timer as well. Screen recording, that comes in the timer interrupt, right? Screen recording, that is timer interrupt. And so there are some program which logs the data. Data logging programs, data logging programs, PRGS programs, reading input, output after every second. And there are the last input, output devices. Clear?
Yeah.
Okay, for example, input, output, a printer, if your printer cartridge that, so for example, printer ink supply notification, let me make it simple. Notification means वो ड्राई होने वाला है, if the paper stuck or jam in the printer. What else can be input? Okay, sorry. Okay, so sometimes you get the message data. This is just telling you. I'm just clearing your concept. Data transfer complete. This is the message when you transfer the data from external drive to your computer. So let me make a formal sentence of it. Data transfer complete. So when you get the signal, the completion of data transfer. Umar, does it make sense?
Yes.
Signal the completion of, yes. So these are the interrupts. Uh, you have to understand that hardware interrupts, what are these hardware interrupts, user interrupts, then we have software interrupts, timer, input, output, devices, interrupts. More
Yes.
clear?
Yeah.